Anyway, good morning. We're going to go ahead and start. Moving on over to what we're going to be doing today. And today, what we are going to be doing is, let me go back up. So if you last remember, we're going to continue the lesson we last had, and that is to graph absolute value equations by finding the vertex and determine the domain and range. But we're actually going to be working on the second one here for absolute value inequalities. So we're going to graph those, find the vertex, and determine the domain and range. I'm going to come on down here. So what you need to know, so it's basically the exact same thing we did earlier. We're going to create the table of values, and we want to make sure that we put the vertex in the middle row. And then pick a few numbers above and below that, fill in the table, and then use those points to fill out our graph, or to plot the points on the graph. Once we graph them, we're not quite done yet, because we do have a little bit of work after graphing them, and that is we're going to have to do that thing where you use the dashed line or the solid line. So you use a dashed line for less than or greater than symbols, and you would use a solid line for less than or equal to or a greater than or equal to sign. So make sure you use those signs to show that you can or cannot pick a point directly on the graph. After you use the right line to create the function or graph the function on the graph, you're going to shade in either above the line, depending on which way the mouth is opening. So if it's a greater than or equal to, then you shade below the line. If it is a less than or equal to sign, then you would shade below below the line. And this one is it's like an extra step from what we did before. So let's go ahead and continue graphing these functions here. So to graph them, enter the domain and then give the domain and range. So let's go ahead and find out where the vertex is. So to find the vertex, remember, we're going to take the inside of the absolute value and set that equal to 0. So x plus 1 equals 0. And I'm going to have to minus 1 from both sides, so x equals -1. Now, -1 is going to be the middle number. And now we pick numbers below and above. So let me go ahead and, wait, no, we're going the other way around. So if I'm going down, and it works too if you wanted to go back the other way, if you wanted to make the up numbers greater and the down numbers less, yeah, it'll work also. You'll get the exact same thing. All right, so now we need to get what we need to from this here by plugging these numbers in for x. So we're going to start off with -4. So -4 plus 1 absolute value. So go ahead and add those together. You would get -3. And you still have to take the absolute value of -3, which, if you remember, the absolute value sign or absolute value operator is going to turn it positive. So I'm going to get +3, and this is our first ordered pair. Let's go ahead and do the same thing with -3, and these ones are kind of they're not as complicated, so I'm going to go ahead and just sort of do them in my, just follow along, we'll do it mentally. Do it in our heads. So -3 plus 1 is -2. So right, we got to take the absolute value of -2, which again just means it's going to turn positive. Let's plug in, let's see, -2. -2 plus 1 is -1. But we have -1 in the absolute value, so we're going to go ahead and turn it positive. And -1, let's go ahead and put -1 in there, so -1 plus 1. And that would be 0. And next one would be 0. X is equal to 0. So 0 plus 1 is +1. And absolute value is always going to make it turn positive, except for sometimes you'll have a negative on the outside. That's the only other time that you will get negatives in this row. But otherwise, anytime you put something into an absolute value function, absolute value operator, it will always become positive. All right, I put in 1, so 1 plus 1 is 2, and absolute value of positive 2 is already 2, so it's not going to change anything. And plug in 2 plus 1 is 3. And 3 is already positive, so let's go ahead and just put that down. Now we have enough points to start putting our putting these points on the graph. So -4, 3. So we graph this one right here, -4, 3. And then -3 up 2 for the next one. -2, 1 for this one. -1, 0. And remember, we put this number in the middle to be our vertex. And we did that so that we can tell where this graph is going to turn. Now you could pick these numbers randomly, or just use whatever method to pick it. But we want the vertex in the middle because that's a crucial point in graphing an absolute value, because again, it's got to look like a V. So you got to know at least where it turns around, the vertex. 0, 1, so 0, 1 is going to be right there. Next one is over 1 up 2, over 2 up 3, and that should be enough to graph our points. So I'm going to go ahead and use our tool to make a straight line from here to here. And I'm going to erase these lines just to make my graph look a little bit nicer. Now, we're not quite done with this yet because we still have to shade one of the sides. In fact, actually, it kind of occurred to me that what I should have done was check the kind of line that we need. So in this case here, we need a dash line. Because we do not have an or equal to, this dash line is sort of a way of saying we can't pick anything that's exactly on the line. So if I were to pick this point here, which seems to be -6 up 4, I would get a statement kind of like 6 is less than 6, which is not true. So if we pick anywhere on the line, it's not going to be true. But if I pick any point like this, it may or may not be true. But anyway, that's the next thing we got to do, is determine where the solution area is by shading one of the sides. So I'm going to go ahead and shade this graph here. So the way I tell you to remember it is that there is a Y on top of the graph, and the mouth is opening away from the Y. So if it's opening away from the Y, we must shade away from the Y on the graph. So anywhere below this line is going to be a true solution. If I plug in any of the points for X and Y for any area down here, it's going to be true. And that's it for that one. Let's go ahead and move on to the next one. Okay, so same thing. And again, whenever we look for the vertex, we are only looking for the numbers on the inside of the absolute value operator. So we are going to ignore the -2 because it's not inside of the, it's not in the bars. So I'm going to go ahead and add 5 to both sides. So this means that 5 is going to be the vertex. So we could expect our line to change direction somewhere on this line. All right, so it's going to go like that. But we need to know exactly where. So again, we're going to have to do the thing where we pick a few points below it. So 5, 4, 3, 2, and go up this way. So 5, 6, 7, 8. Now I'm going to go ahead and On some of these, we may need to do some work. But anyway, plug in 2, so that's 2 minus 5. 2 minus 5 is negative 3 minus 2. So I just did one step here, so plug in 2 minus 5, and that's how I got negative 3. But if I take the absolute value of negative 3, I'm going to end up with positive 3 minus 2. And that's going to be what we're going to put in here. So 3 minus 2 is 1. Now let's go ahead and plug in 3. So 3 minus 5 is negative 2 again. And I'm going to do this a couple times. We'll probably end up doing it we'll end up doing it mentally. So negative 2 absolute value minus 2. So that's going to be positive 2 minus 2. And that's going to be 0. So 0 is going to go right here. 4 minus 5 is negative 1. But we're going to take the absolute value of negative 1, which is positive 1. Positive 1 minus 2 is negative 1. And let's punch in 5. So 5 minus 5 is 0. And 0 doesn't have an absolute function because 0 is 0. And remember, that's exactly what the absolute value means, is a number's distance from 0. So 5 minus 5 is going to be 0 minus 2, so that's going to be negative 2. And let's go ahead and plug in 6. So 6 minus 5 is 1. We take the absolute value of it because we got to use up this absolute value before we subtract the 2. That kind of brings up an interesting point, but I'll get to that in just a second. 6 minus 5 is 1 minus 2. So that would be negative 1. And again, if this middle point is indeed our vertex, we should kind of have like a mirror of these values in here. But just in case you made a mistake, it's probably best to continue solving all of them or evaluating all of them. So 7 minus 5 would be 2. 2 minus 2 is 0. And 8 minus 5 is 3. 3 minus 2 is 1. And there we go. Now, one interesting thing about the absolute value sign. So in the order of operations, where do they go, right? So do you do them first? Do you do them second or third? Well, absolute values count as a grouping symbol. So you kind of treat them like parentheses. If you see an absolute value sign, you got to do what's inside the absolute value sign first. Anyway, let's see, what do I got? We got to plot these points here. So over 2, up 1. 3, 0, so over 3, and we don't move up. Over 4, down 1, so over 4, down 1. 5, negative 2. 6, negative 1, so over 6, down 1. And just as we expected, I put that yellow line there, or that orange line, so that we know very likely where it is going to turn around. And if I keep plotting it over 8, up 1, it does make a nice V shape. And for this one, we need to plot the correct type of line. And I don't know why my lines came out silver today, or purple today, but I'm going to go ahead and just leave that the way it is. And there we go. So we have our graph, and I'm going to erase these things here. They're not really part of our answer. We don't really need them. But what we do need next is to fill out a part of the graph where these solutions are. Now this one's inequality is opening the opposite direction. So you could probably tell it's going to open upwards, or the opposite side of the other one. But again, if the mouth is open towards Y, that means you shade towards this Y on top of the graph. And most graphs have a y or x label, x axis labeled. So we got something like that. So the top of it is labeled, shaded. Okay. So that takes care of that. Let's go ahead and move on to the next one. All right, so I'm gonna go ahead and do this one. I'm gonna kind of increase the speed a little bit. We don't have that many to go. We only have like 6, and then we're, all right, so 4x plus 6. 4x plus 6, and we're gonna have to solve it. So I'm gonna have to minus 6 from both sides. So 4x minus 6. And I'm going to have to divide both sides by 4. So x equals negative 6 over 4. But I'm going to have to reduce that. If we reduce it, I get 3 over 2. Or x equals 1.5. So that one did require a little bit of work. Oh, it's negative. Should be negative. Almost forgot that negative there. So before I forget, let me go ahead and mark my axes. People say axes. That's like the most common way of saying it. There's no need to complicate language more than you need to. Some people just say that way to be fancy. All right, so now we put negative 1.5 in here. And now we pick numbers below it. So if I start right here on this purple line, which you don't need to graph that, I just drew it, and you might want to draw it a little bit lighter so that way you don't have any trouble erasing it. So anyway, let's go ahead and go down to the next number down, and that's negative 2, negative 3, negative 4. And here I'm going to go up. So going up here, we got negative 1, 0, 1. All right, let's start filling out this side of the table. So negative 4, oh boy. So negative 4 times 4 is negative 16 plus 6. And in that case, you would get 10. And don't be afraid to write them out, okay? If you need to work on these on a separate sheet of paper, that might be the best thing to do. But even for me, I didn't, when I made these slides, I didn't give myself enough room to write all of the workout. So, but don't be afraid of writing your workout. So anyway, let's continue on. 4 times negative 3. So 4 times 3 is 12, but it's going to be negative 12. Negative 12 plus 6 is going to be 6. Well, actually be negative 6, but I'm going to have to take the absolute value of it. So it's going to become positive 6. And then for this one here, I have negative 2. So 4 times negative 2. 4 times negative 2 is negative 8. Plus 6, that would be negative 2. Wait. But then I'd make it positive, so it'd be positive 2. And for this one here, since it's in decimal, I'm going to go ahead and 1.5 times 4. And I get 6, which is, actually would be negative 6, but I'm using a calculator that does not account for the negatives. So that would be negative 6 plus 6, which would be 0. And absolute value of 0 is 0. Negative 1, so let's see, negative 4 plus 6. Negative 4 plus 6. That would be 2. Or, yeah, wait. No, that would be the same as 6 minus 4, which is 2, yeah. Okay. And then 0 times 4, anything times 0 is going to be 0. 0 plus 6 is 6. 1 times 4, so last one. 1 times 4 is 4. 4 plus 6 is 10. Take the absolute value of it. It's already positive, so it just stays positive 10. Now, this graph only goes up to 8, so I won't be able to graph that high. So we'll start at this point here, -3, 1, 2, 3, up 6. And then -2, 2, -2 up 2, -1.50, -1 up 2. And we get a really, I mean, if you look at the graph, the function that we're graphing, it's really narrow. We have a really sharp graph then. Well, actually, we would call that vertical stretching because, again, you imagine that it's written on something like rubber or stretchable paper, fabric, or whatever, and you pull it this way. You know, maybe you've done something like that, like I don't know if they even have fun house mirrors anymore. But if you've ever seen it, they're mirrors that make make your shape distorted. Okay, so let's go ahead and move on to the next one. And this one here, before we even started, I'm going to point it out that we have a negative on the outside. And anytime that happens, okay, so anytime you have a negative on the outside, that has the effect of mirroring along the y-axis, I'm sorry, the x-axis, what we call reflection about the y-axis. So you can kind of see here, I'm adding and taking away that minus. So now it's going to open downwards. And you know what, while we're at it, we could probably even just punch in what we're looking at on the paper. So we can see that it's kind of a narrow graph opening downwards. In fact, actually, you know what? I think you can even do the graph like an inequality. Oh, hey, what do you know? You can. Now, in this case here, we have the, okay, but you're still going to need to finish out the table, all right? So you won't be able to use this to do your homework because you still need to fill in the table. But you can check your work with this. You know, if your graph is way off, you can easily tell, you know, well, I learned something today. I think I might have tried that before, but now I know for sure that you can graph these using Desmos. But so far in this course, I haven't really found many things that Desmos cannot do. Anyway, so let's go ahead and continue. So take what you have inside the absolute value and set it equal to 0. So again, the negative and the 3 don't count. We only look at what we are doing inside the absolute value bars. So in this case here, we have a reflection about the y-axis. Okay, no problem. But again, we probably also saw that looking at our graph. So anyway, if I put in 0 here, I need to pick some numbers below 0. Okay, that looks like it's a double negative, but it's not. It's just a extra little piece I put in there. 1, 2, and 3. Evaluate each of these for the value that you put in there. So -3 times 2 is -6. So if I put my first value in there, I get -6 on the inside of the absolute value sign. Now this one's a bit tricky because again, there is a negative on the outside. And this is just like taking clean clothes out of the washing machine to put them on a clothesline to dry, but then they end up falling off the clothesline into the dirt, right? This 6 got clean. That's not negative anymore, but this negative out here is not affected by it. So just like if you put clothes on top of the washing machine, it's not going to get your clothes clean. You got to put it on the inside. But this negative is going to jump onto the 6 once it comes out. So now your clean clothes are dirty again, or negative in this case. And now you end up with a negative number. So -6 plus 3 would be -3. Let's go ahead and put the next one in there and keep that in mind as we go through this, because even though this is an absolute value, we are going to get a negative out of it. 2 times negative 2 is negative 4. Negative 4, if we make it into an absolute value, it's going to be positive 4. But this negative is going to jump on it again. So we end up with negative 4 plus 3, which is negative 1. Negative 1 for this one here, plug that in. Negative 1 times 2 is negative 2. And negative 2, absolute value would be positive 2. But again, it's going to be made negative by this thing on the outside. So negative 2 plus 3 is 1. And 0 should be easy to work with. Anything times 0 is just 0. So this is 0. You can't make it negative. So even if you said negative 0, it would still mean the same thing as 0. 0 plus 3 is 3. 1, plug in a 1 in there. So 1 times 2 is 2. And make it negative. So again, even though it was positive and its absolute value, this negative out here is just going to jump on whatever comes out. So negative 2 plus 3, or 3 minus 2, is going to be 1. And again, don't be afraid to do your work like this, okay? I'm just doing this to save myself some writing. And I didn't give myself space in the slides. So 2 times 2 is 4, which becomes negative 4 because of this negative here. Negative 4 plus 3, or 3 minus 4, is going to be negative 1. And last one, plug 3 in there, so we get 6, or negative 6 because of that thing again. Negative 6 plus 3 is negative 3. And it should match, okay? We should have a matching set in both directions. Anyway, let's go ahead and graph this now. So negative 3, so back 3, down 3. Negative 2, negative 1. Negative 1, up 1. 0, 3. And again, this in transformation terms, this moves your graph up or down. Over 1, up 1. 2, negative 1, over 2, negative 1. 3, over 3, negative 3. And I'm going to go ahead and connect my dots as best I can. Oh, man. You know, before I forget, I just noticed that I did not check the kind of lines I need on this one. So make sure when you're working on these that you check the kind of line that you need. For these ones, the type of line is crucial. So I think it's just that number 2 is already a solid line and I just didn't check it after that. But in this case here, we do need a solid line for this graph because of the or equal to. Since there is an or equal to, that means I can pick areas on the graph and still get a true sentence. Now we just got to shade these graphs. So remember, if it's opening towards the Y, we shade the top side. Okay, that's the best I can do. If it's facing away from the Y, so that mouth is opening away from the Y, remember there's a Y on top of the graph, that means we go away from it. So we shade the opposite side from this one. And again, if it's open towards the Y, then it's towards the top or towards the Y on top of the graph. Okay, last set. All right, so I'm going to go ahead and put these in, take the absolute value, so 2x minus 12, and set that part equal to 0. All right, so I'm going to have to add 12 because I'm trying to get that x by itself. Add 12 to both sides, so 2x equals 12, and in this case here, x equals 6 because I'm going to have to divide both sides by 2. Divide by 2, I get 6. So x equals 6, and I don't have to mark it here, but I like doing it sometimes where I mark The actual name is called the axis of symmetry, but we don't really need that. Like I said, it's not part of our answer in this case. That line's going to be erased later, so don't make it too dark. Okay, so let's go ahead and put 6 in the middle because we know that this is going to be our vertex. So 6, 5, 4, 3, and make some numbers above it, which I think this last one's not going to be able to get onto the graph, but that's okay. All right, now plug these numbers in for x. So for 3, 3 times 2 is 12. I'm sorry, 3 times 2 is 6. So 6 minus 12 is negative 6. But because of the absolute value, we are going to have to make it positive 6. So positive 6 minus 7 is negative 1. And then we're going to do the rest for all of these here. So plug in 4. 2 times 4 is 8. 8 minus 12 is negative 4. But again, it's going to be positive because of the absolute value. So positive 4 minus 7, and that's going to be negative 3. Plug in 5. 5 times 2 is 10. 10 minus 12 is negative 2. So negative 2, take the absolute value, that'd be positive 2. 2 minus 7 is negative 5. Negative 7. And sometimes you can kind of see a pattern. Down 2, down 2, down 2. Now, if this is our vertex, that means it should be, this next number should be negative 5. So 7 times 2 is 14. 14 minus 2 is, I'm sorry, 14 minus 12 is 2. Positive 2. And absolute value of positive 2 is still 2. So 2 minus 7 is negative 5. So there we go. We know that this is going to be our vertex. And like I said, just in the interest of time, I'm just going to go ahead and mirror the results because I already know they're kind of right. But for you, you probably should do all of them. Over 3 down 1. Over 4 down 3. Over 5 down 5. Over 6 down 7. Over 7 down 5. And over 8 down 3. And again, we should have it symmetrical on both sides. And let me check what kind of line we need in this case. Make sure I do it in order this time. So in this case, we're going to need a solid line. So let me join these points as best I can using a solid line. And I'm going to just erase some of these to make my graph a little bit nicer. And there is our graph. We've got to make sure to shade the right side. So in this case here, mouth is open towards the Y. So that's the Y we go and shade it towards. So shade the top of the line. Easy peasy. All right, so last one. We have a negative. So before you start graphing, we should start looking at some of the things that we should notice about this. This is negative, which means our V is going to open downwards. So, well, there's no such letter as an upside down V. Well, there is. It's called lambda. And it's a letter that, well, it's Greek. But if you've ever seen like the 300 Spartans, they have that thing. That's just a letter. It's like the letter L on their shields. So that upside down V is just the letter L. But there's more to it anyway. Let's go ahead and just do that. But anyway, it's going to look like an upside down V. Let's go ahead and I'm going to do the workout here because I think some of these have been taking a little bit of space. So 3x plus 9, right? That's inside the absolute value. I'm going to minus 9 from both sides and divide both sides by 3, and that should give us our axis of symmetry. So we know it's going to turn right here on this line. So let's go ahead and put negative 3. right here and pick some numbers below -3, so -4, -5, -6, and then we need to pick some numbers above it, so going up from -3, -2, -1, and 0. Take these numbers, and again, you can pick them randomly, but you got to make sure you find the area that it turns around at. Otherwise, if you never see it, you might just make a straight line, and that's not going to work either. So let's go ahead and plug in -6 in for each of these numbers in for x, starting with -6. Now again, there is a negative, so this means that whatever comes out of this absolute value sign is gonna become negative. All right, so 3 times -6 is -18. -18 plus 9 is -9, but absolute value of -9 is +9. But this is going to turn it negative. So -9 plus 4 is -5. -5, plug this one in here for x, that'd be -15. -15 plus 9 is -6. It will become +6 because of the absolute value, but it will be made negative by this number here, so that becomes -6 plus 4, which is 2. Plug in -4, we get -12, plus 9 is 3, make it negative. -3 plus 4 is 1. -3 times 3 is -9. -9 plus 9 is 0, and it doesn't matter because there's no such thing as -0. It just becomes 0. But in this case, actually, it would be 0 plus 4, so that would be 4. It's not a very good 4. Let me make that 4 a little bit better. And here I got -2, so plug in -2, so that would be 3 times -2. That would be -6 plus 9, which would be 3, and it's going to be made negative by this one here outside. -3 plus 4 is 1. -1 times 3 is -3. 9 minus 3 is 6. Make it negative. -6 plus 4 is -2. 0 times 3 is going to be 0. 0 plus 9 is 9. -9 plus 4 is -5. And that was a little bit of work, but you know, they're all kind of like that. And again, when you're doing the work, don't be afraid to write it out. Okay. I'm just doing it just so it goes by a little bit faster, and I didn't give myself any space to write this. So let's go ahead and graph this out. Oh, no, I just went straight to my graphing tool. But you know, I wonder if that'll still work. Let's try that. -6, -5. -6, -5. So our line definitely passes through here, -6, -5, -5, -2, -4, 1. So -4, 1 would be right there. -3, up 4, that would be right there. And then from here, it goes from -2, 1, and it goes back down to 1. So my line, the vertex, and I marked it with those little kind of like arrows there. So I know it's going to kind of go through this. And let me make sure it goes. Now, it would have been a lot easier if I just left the marks on there. But I'm just showing you that there's other ways to do this. There you go. And it should pass through the points continuing. Let's go with -2, 1, right? It passes right there. -1, -2, so it passes through that point there, and 0, -5. So just by mirroring it, we can still get a very good idea of the graph. Now, the last thing we got to do is shade it in. So to shade it in, we got to look at this mouth thingy here and determine which way the shading goes. So the mouth is open away from the Y. So we go away from this Y. So we can't shade anything on that side with the Y. And we shade the bottom side now. It's a little bit, I missed a little bit here. That's okay though. But make sure when you're graphing this, it's going to be a little bit closer. Now, let me go ahead and I'll tell you, we're going to be doing something else a little bit more today. Although I'm not really sure exactly what I'm going to do. Let me just go back to the regular screen and I'll tell you what we're going to be doing.